Again, let's deal with Chapter 10, and that's overall system architecture. Now, up to now, we've dealt with the data, we've dealt with the people, we've got an idea of how the organization's set up, but now it's the physical layout of this system. Okay. Go through, provide a checklist of things we need to consider when it comes to selecting the right system architecture, look at the different types of architectures, and understand what client server is and e-commerce, etc. So, issues that influence architecture choice, whether it's a corporate organization or what their culture is. Do they have ERP planning in place or ERP in place? What is the TCO or total cost of ownership of this system? Is it going to be scalable? Do they need it to be scalable? Does it have to interact with the web or have web integration? Are there legacy system interface requirements? Are there processing options, security issues? Do we need a corporate portal? So go through each one of these. Excuse me. Sorry about that. Now, a successful system performs well in a company's organization and culture. And everything that we've done up till now, we've embraced what their culture is, what their mission statement is, and we know where this company's going and what they want to do, how they do it. We've looked at, does it fit in as far as the different feasibilities, and we understand the total cost of ownership, what it's going to take not just to pay for it to happen, but the time and human resources associated with the ownership of this new system. All right. Now, we've got different topologies, if you will, or architectures. Now, we've got client-server environments. We have a client machine connects to a server. Now, when we think of server, you think, well, I went out to dinner last night, the server brought me dinner. It's the same concept. A client computer or system connects to a server and asks for resources, requests them. And the resource could be a web page, a file, an email, data. There's so many things that can be served out from a centralized location. Now, by doing it this way, we've got centralized control, and we control access as well by user accounts. Now, decades ago, mainframes were the big thing, and they were very large systems. From mainframes, we've gone to what we call smaller servers. It's not an all-in-one thing. We'll have redundancy of servers. Now, this redundancy of servers allows us higher reliability, faster response. Should one fail, we have others that are ready to go and still working. Now, we've got different types of networks, local area networks and wide area networks. And wide area, it's just the difference in how big the distance that we're spanning is, whether city to city or within an organization. Here's a graphic that shows both of them. A client-server architecture, the client requests something, the server shares out whatever that resource may be. Okay. Now, there may be a system where we've got multiple tiers in that you connect to a web server, and that web server then connects to a database, which is another server. It's very common that we'll see that take place. The internet has allowed us to increase centralized control of resources as well as allow access to a broader range of clients or users. Now, Web 2.0, it's the second generation of the web and enables people to collaborate, interact, and share information more dynamically. It's considered a step towards a semantic web. Now, we talked about what an in-house solution was as compared to a canned solution. And an e-commerce architecture is one in that users or clients will interact or perform commerce, trade, with another entity through a server or a client server environment. We see that in Amazon.com. I can go buy just about anything from Amazon through their server. I don't interact with an individual at all. Now, we can have the processing take place online, and it could be on the server that we're dealing with, or it could be another entity. We saw that in the functionality diagrams. Okay, so the OSI, or Open Systems Interconnection model, is a way that we can see how, now graphically, we don't actually see it happen. A user interacts with an application, the application interacts with the hardware then sends that request across a network connection, and then it works its way right back up to an application on another computer. It's seamless, we never see it take place. Okay. So we've got different topologies, and these are the physical or logical layout of a computer network. We've got a bus network, they're all connected to a common trunk. We've got a ring network that looks like a circle, and on that one, it's like, we call it a token ring network. Data flows one direction, and there's like a little token or coin that's passed around, and you can only talk on the network, say something, if you possess that ring. So the ring would be passed, or token, I should say. The token we passed around, you receive the token, you could say something. And then you throw the token back out, and it would go to the person that you sent that message to, and it would go round and round. It's not common that anybody uses this anymore. We'll deal with a star or a mesh network. So here's a normal network topology. This being a star, you've got network servers, departmental servers, terminals with the client machines, PCs, client machine, connecting to a server or any of these departmental servers. This is a normal topology that we would see today. Okay, here's a bus network. They're all connected to a common bus. If this fails here, nobody gets to the server. Or if it fails about where the word bus is, nobody past that word bus can connect with the server. The only people that would have connectivity would be the PC and there's a couple of terminals there. So anybody on the other segment of that bus will not have access. Now here's that token ring. It goes round and round. This was not even a token ring, it's just a ring. Only goes one way and is very ineffective. So here we go, we've got the mesh to the right and the star topology on the left. And the star is one of the most common, and a hybrid of multiple stars is what we saw in that last model. Okay, a proxy is a go-between so that your computer talks to that proxy and then that proxy talks to the internet for you, gets whatever you need, and then brings it back and delivers it to you. Now we've got wireless access points, and they just allow us to access the networks much like the topologies we just dealt with. Now we've got wireless network standards, or let me back up. The IEEE is the governing body that dictates what these standards are. And it's 802.11 is the number. The current standard is 802.11ac. Older ones, G, N, and the like. If we want to be backward compatible with them, depending on the system that we're using, what that may mean is, and the older ones are very slow compared to what we're dealing with now, if we want to allow connection to our system by a legacy device, oftentimes what that means is the entire network will slow down to that legacy device's speed so that nobody else can use the faster speeds associated with, say, 802.11ac. Okay. Now, covered a lot in the past few chapters. And in this one, we just dealt with hardware, different topologies, and different ways to connect, whether it's wired or wireless. Okay, different system architectures, client-server, and what client-server means. All right. So we'll see you in the next